Okay.
We will
Shall we
wait for two
wait?
more minutes, ma'am.
Okay, fine, sure.
Okay, ma'am.
Okay, fine.
Don't go early, ma'am.
Sir, should
Start
I
பண்ணலாம்.
start, sir? Oh,
Yeah,
okay,
yeah,
sir.
start.
Okay, sir.
Arun sir, shall we start?
Yeah,
Yes,
yeah,
sir.
sir.
Arjun,
Start
sir, we
பண்ணிடலாம்.
can start, sir.
Okay. Good afternoon to all. On behalf of Pannamalal Institute of Technology and EC Department, I welcome all the participants for the AICT sponsored Sttp on Mission Vision for Entrepreneurs Launching Startups with No Seed Fund. It's very much immense pleasure for me to introduce the speaker of the session, Dr. S. Venkata. Dr. S. Venkata currently serves as a professor in the Computer Science Engineering Department at Sri Krishna College of Engineering and Technology, Coimbatore. She received a doctorate degree of Computer Science and Engineering from Manamaniam Sundarnar University in 2018. She has an experience of around 20 years in teaching and published journals in peer-reviewed journals, patent and book chapters in her area of interest, and also presented papers in various international and national conferences. Her research area interests includes image processing, artificial intelligence, network security, and information retrieval. She is a member of IEEE Computer Society and CSR. She has organized a number of conferences, workshops, staff development programs, and seminars. She shines in her various responsibilities such as NAT coordinator, NBA coordinator, and entrepreneurship skills coordinator. She was a smart worker who managed time efficiently, examined a problem from all perspectives, and arrived at the best solutions. Multidisciplinary approaches, the ability to work both independently and in teams, alignment to up-to-date context, and mental alertness all shown through in her efforts. Clearly, you are playing a vital role in the technological field, ma'am. Welcome you, ma'am, from the core of my heart for the today's session. I take the pleasure to handing over the session to Dr. S. Venkata.
Thank you, Navarajan sir. Thank you. Am I audible?
Yes, sir.
Okay, sir. Thank you, sir. Thank you for the invite.
Thank you.
Okay, very good afternoon to one and all present here. I think I've given sir has given a wide introduction. So thank you, Arun sir and EC HOD ma'am for giving this opportunity. So I'm here to discuss about the topic machine vision effects in artificial intelligence and its challenges. So let me present the slide. So this is what the topic is: machine vision effects in artificial intelligence and its challenges. So the content which we are going to discuss here is the introduction about the machine vision, the components of the machine vision, why we are using machine vision, some of its examples, then machine vision in artificial intelligence, what are the techniques that is used in the artificial intelligence, applications related to that artificial intelligence with machine vision, and challenges, benefits of AI with machine vision, what are the related goals and the related search. And what are the related recent related researches that was happening with the AI in machine vision and other references. This is what the contents I'm going to discuss here. So machine vision, actually it is a guide of automating process and the quality improvements. So according to the Automated Imaging Association, that is AIA, machine vision, it encompasses all the industrial and non-industrial applications. In which a combination of hardware and software is called as a machine vision. So hardware is provided by the machine and the software is supported with the help of artificial intelligence. So this is what the combo of machine vision with artificial intelligence. So it will provide operational guidance to devices in the execution of their functions based on the capture and processing of images. So, what is the relationship between the machine vision and AI? If you say, so machine vision is the ability of a computer to see. It employs one or more video cameras and analog to digital conversions and digital to digital signal processing is there with machine vision. So the resulting data will be a robot controller or a computer. So that will be the resulting data. So machine vision is very similar in complexity to voice recognition. So AI supports the machine vision with the technique. So that is what the relationship between the machine vision and AI. So we may arise with a question that machine vision and computer vision is that similar. So machine vision, it uses a camera. Am I audible? Is there any issue? Am I clear?
No, ma'am. You
Okay,
are audible.
Okay, fine. Thank you. Okay, fine. So, so machine vision, it uses a camera to view an image. So computer vision is an algorithm. It processes and interrupt the image. So computer vision, it uses an algorithm and then it processes and interrupt the images before instructing other components in the system to act upon the data. So this is what the relation or the difference between the machine vision and the computer vision. So AI's applicability in machine vision, it relies on affiliated branches of the machine learning, deep learning, then artificial intelligence. So like that, it continues with that. So AI computer ability to simulate the human intelligence, that all we know. So machine vision, it requires a computer with the advanced processor, with a high resolution camera, and with large amount of random access memory. So AI is a programming that helps in the machine vision to have a depth perception. So that is what the relationship between the machine vision with the artificial intelligence. So machine vision is used in various applications, especially in industrial application and medical applications. That is with the machine vision. So actually, the definition, when you say the machine vision is a process of extracting some information from the visual sensors. So to enable the machines to make it intelligent. So that is what the machine vision is. So the key points here we say is automated. It's automated or it is non-contact. So an automated in the sense we are using some ultrasonic. And automated in the sense we are using some ultrasonic scanner, and that is based on the non-contact air-coupled technique. So it is designed and developed on that. So that is non-automated and non-contact. And acquisition, so the image acquisition, as all we know. So the representation of the visual characteristics of the object, such as the physical scene or some interior structure of an object that can be identified. And the data can be analyzed and it can be processed. So that is the key points or takeaway from the machine vision. So machine vision, so it covers all the three areas. One is the image acquisition, second one is analysis of images, and the third one is integration and applications. So image acquisition here it covers with the, we are using so many sensors. So sensors, optics and the lightning. So that is with the image acquisition. And with analysis, so that components that is used for acquisition that can be analyzed. So analyzed with some techniques. So the techniques here, so you can use some software or algorithms to make use of that components better. And finally, that can be used for some application. So integrations and applications and the communication, automation. I'm getting some disturbance. Is there any problem? Okay. I think, okay, fine. Okay, fine. So integration and application. So it results the components with the acquisition. So that results with some implementations, and the communication and automation can be done with the machine vision. So these are the major components with the or points with machine vision. So how does this works means you have an image, three steps for working. One is image capturing, second one is processing of images, and the third one is action on the processed image. So these are the three different steps. So image capturing, in the sense we need visual sensors. You can use either vision sensors or you can use some cameras for capturing the images. So that takes us a snapshot. So it takes a snapshot through one or more instances, and the hardware captures the image and that gets converted into a digital form. Processing of image. So pre-processing and image recognition is done with the image processing here. So pre-processing, it consists of some noise, so that will be removed, and contrast enhancing will also be done with the images, and then it is given for some segmentation and feature extraction. So feature extraction like size, color, length, shape, so like that features will be extracted and it gets processed. So that is the image processing. That is the second step in the machine vision. And the third step is based on the images extracted. So with the previous image pre-processing and feature extraction, so the machine is instructed to do a necessary action. So that is a third step, system action. So altogether is called as a machine vision. So image capturing, processing, and action. So these three combined together as a work of the machine vision. And this is one small example. The example of the machine vision. So, okay. So consider a fill level inspection system. So each bottle should pass us through a inspection sensor. Okay, fine. So each bottle passes through the through an inspection sensor, which triggers a vision system. So to flash a strobe light and a picture of that bottle. So after acquiring an image and storing it in the memory, I think somebody is not muted. Hello, Arun sir.
Yes, ma'am.
Pongulan ma'am, you want somebody has to be muted. Some noise is disturbance is happening at the.
Oh, is it, ma'am?
I don't
Everyone is
know.
muted, ma'am. Everyone is
Okay.
muted, ma'am.
Okay, fine. Okay. So okay, fine. Okay, so after, so this is what the example is. So consider a fill level inspection system, and each bottle passes through a inspection sensor, and which triggers a vision system. So the to flash a strobe light and take a picture of a bottle. So after acquiring the image and storing it in the memory, the vision software process and it analyzes it, and it issues a pass or fail response. So the based on the fill level of the bottle. So if the bottle detects an improperly filled bottle, a failed signal is rejecting the bottle indication will be given. So an operator can view the rejected bottles and ongoing process statistics on the display. So in the vision system display, they can see the rejected number of bottles and the ongoing process of the statistics that can be seen in the display. So this is what the machine vision is. So the machine vision can process, analyze, and measure various characteristics for a decision making. So this is what an example of machine vision. Here the strobe that is used to study the behavior of the rotating machinery. So oscillating vibration of the components can be easily identified with the help of the strobe. Components of machine vision. So lightning, lens, communication, vision processing, and sensor. So these are the major components of machine vision. Okay. Why do we use the vision? So since there is remotely, if any process that is remotely situated, to identify that particular process, that component, or if the for flexibility reasons and for affordability reason, for dynamic range of communications, so we'll be using this machine vision for that support. So machine vision, it includes the following elements. One is image acquisition, second one is image pre-processing, third one is feature extraction, fourth one is decision, and the fifth one is control. So image acquisition, so we know, so we are capturing an image, pre-processing, the noise and the contrast has to be enhanced, and feature extraction, so the height, length, width, the color, different features will be extracted, and the decision has to be taken by the machine. So it has to be decided by testing out the part component, and then it has to be decided. And the control is it gives the result of the programmable logic controller or some robot controller for identifying the process. Okay, so this is what the steps involved in the machine vision. So image acquisition, it transforms a visual image of a object, physical object, into a digitalized data. So that is what the image acquisition. So images are formed, it gets detected, sensed, and it gets converted into a digital transformation. And image formation and detection. So the vision system, so the images is formed by illumination from an object. So by optics or through a photosensitive detectors. So it gets images are formed and it gets detected and it gets processed. So image formation can be with the help of a shape lightning, or it can be with a feature of relative positions, or with a sensor sensitivity. So the same shape can be detected with different images with different features. So that can be easily identified, and the machine has to be practiced on or tested on that particular component. So these are the different types of lightnings. Lightnings related to the machine vision. So before getting into that, 2 minutes of video. So why we are using this artificial intelligence and the machine vision.
Not all machine vision and artificial intelligence are created equal. So how do you tell which solution is best? We know what it takes for these technologies to accurately surface patterns and identify risk. Now we'll see how Lytics proactively detects risky driving with high precision to serve up opportunities for coaching that inform without overwhelming. At Lytics, we combine video telematics with machine vision, artificial intelligence, and driving data to help solve our industry's most critical problems, like distracted driving. We tap into over 100 billion miles of driving data that we've collected over the years. But why is this so important? And why should you care? Because high-quality, validated data is the best way to train custom artificial intelligence to deliver the most accurate results. What sets our data apart? For starters, our unmatched volume of high-quality data gives us a more complete view of true risk. Then there's variety. Diverse information helps separate anomalies from confirmed patterns across a wide range of driving scenarios. Another key element is the velocity, the speed at which we capture data. Collecting lots of data quickly helps us update and improve our artificial intelligence technology. So it's always learning, refining, and getting better. But all this input doesn't matter if it's delivering useless information. And that's why our professional analysts work 24/7 to meticulously label high volumes of data. What does this mean for your fleet? Value. Lytics cuts through the noise to deliver moments that represent true risk throughout your driver's day. This lets you focus on coachable moments that actually matter and make a difference, keeping your drivers and fleet protected and your business running smoothly.
So that is what the relation between the artificial intelligence and the machine vision. So why do we need a machine vision?
ProScan's Introduction to Machine Vision, an educational webinar series to help new users better understand the basics of machine vision technology. This is the second installment in our series, and in this presentation, we're going to cover the why of machine vision. What benefits can it bring to the factory floor? I'm going to talk about 4 ways that machine vision can help manufacturers save money, and why this automated process is better suited to repetitive inspection tasks than human inspectors. If you tuned into our previous presentation, then you already know what machine vision is and its 4 most common applications: measurement, counting, location, and decoding. You might use these tools to achieve a number of different ends, but the motivation for doing so is generally like all others when you're applying industrial processes: to save money and increase profitability. Thinking in these terms, machine vision accomplishes this in several ways: by reducing defects, increasing yield, tracking parts and products, and facilitating compliance with regulations. Machine vision inspection can reduce defects or cause what we'll call fewer catastrophes, fewer bad parts getting out into the world and into customers' hands, which could damage a company's reputation and lead to costly product recalls. Along those lines is preventing mislabeled products, parts where the label doesn't match the content. Mislabeled products create unhappy customers and have a negative impact on a company's brand. They may even pose a safety risk. Consider the consequences of improperly labeled pharmaceutical products or mislabeled food items for customers with allergies. This is a very common reason for product recalls. Machine vision can verify contents and ensure that products are labeled properly. Here's the label matching application we showed you in our last presentation, where we use machine vision to read the 3-letter text or OCR code on the top of a vegetable can to match it to the correct label. Another incentive for machine vision is better yield. Simply the ability to turn more of the input material into saleable end product. If you catch defects early in the production process, you'll reduce waste, because bad parts can be identified and eliminated before they're built into larger assemblies. You'll avoid scrapping expensive materials and reworking parts. This image shows a molded lead frame, an electronic part that our vision system is measuring to detect any deformation. By detecting defects at this stage, we'll avoid having to scrap larger assemblies later on in the process. Machine vision helps to reduce downtime, another benefit that falls under this category. For example, a packaging line may use a vision system to detect product misfeeds that could cause the machine to jam and result in downtime and loss of product. In the case you see here, a vision system is ensuring that these baked goods are properly aligned as they travel down a conveyor. Items that are out of tolerance will be expelled from the line before they can cause a system jam. I'm sure you're aware of the usefulness of tracking work in process, or WIP, uniquely identifying products so that they can be tracked and traced throughout the manufacturing and stocking process. Machine vision can be very helpful here. Typically, if you can identify all of the pieces in a process, you'll require less stock, and product becomes available more readily for just-in-time processes. Machine vision uses decode tools to read 1D and 2D symbologies, as well as OCR to track parts and products. This helps manufacturers to avoid component shortages, reduce inventory, and shorten delivery time. This is also where the Auto ID Plus aspect of machine vision can be beneficial. Of course, track and trace applications such as this are commonly accomplished with dedicated barcode readers or imagers. Machine vision provides the added benefit of being able to perform other tasks, such as alignment or measurement, in addition to reading barcodes and OCR. As an example, you may want to read a data matrix code on a PCB, and also verify its location on the board. Complying with industry regulations is often an unavoidable cost, but if you don't comply with the regulations relating to a particular product, you may not be able to take part in that market. Being able to do so efficiently and at low cost is clearly beneficial. The pharmaceutical industry was an early adopter of machine vision for this reason. It is, of course, a highly regulated industry and requires strict adherence to government regulations to ensure product integrity and safety. A common application we see here is the verification of lot, date, data matrix, and other code formats, a requirement for compliance with standards such as 21 CFR Part 11 and GS1 data standards. Unlike a dedicated barcode reader, a vision system has the capability to not only read the codes, but to verify that the labels are printed accurately and legibly, ensuring that they are readable later in the supply chain. There's also the broader question of, why use automatic systems like machine vision to do things that you could potentially do with human inspectors? The answer is, quite simply, machine vision systems never get tired. They excel at repetitive tasks. Once they're set up to do an inspection, they will do it all day, every day. Whereas with human inspectors, you would typically expect to find an error rate going up after about 20 minutes on a particular task. Machines do it faster. You can inspect things more quickly with a machine. The other great benefit is consistency. Once the rule is set, it's set and will stay set. People who are inspecting or operating a process have a tendency to change the rules as they go along. So that should give you some pretty clear justification for using machine vision. Let's review. Machine vision helps manufacturers increase their profitability by reducing defects, increasing yield, tracking parts and products, and facilitating compliance with regulations. We also compared the benefits of machine vision to human inspectors. Machines are faster, more consistent, and can run for longer periods of time. With so many compelling reasons to incorporate machine vision, you're probably ready to learn what you'll need to put a system in place. In the next installment of our series, we'll take a look at the different parts of a machine vision system and learn how they all work together.
So that is what the usage of machine vision, why we are using machine vision with the other applications. Coming back to the presentation. So, lightings. So when we see the machine vision, so there are different the different types. These are all the different types of lightings. One is structured lighting. Second one is directional backlighting, diffuse backlighting, then fiber optic or LED ring lights. So these are all the, this is a basic, and still we have too many lightings. One is a structured lighting. So structured lighting, here it represents, it's a process of projecting a known pattern to a scene. That is called as a structured lighting. So with the identification itself, the object is identified and it is projected, the process of projecting an object to a known pattern onto a scene. That is called as a structured lighting. It is mainly used to calculate the depth and surface information of an object in the scene. So that is what the structured lighting is. And the second one is directional backlighting. So directional backlighting, it represents multiple view display and multi-directional display. So that is what the directional backlighting is. And diffuse backlighting, so that it is scattered by particles, so it appears to come from all the directions. So in the last of the diagram itself, it was shown that it was scattered by particles and it can be appeared to come from all the directions. That is called the diffuse backlighting. And fiber optic or LED lighting, so that represents the uses of fiber optic as a light pipe. So it transmits lights from a source through the fiber to a remote location. So that is what that lighting is. Polarized lighting. So this can be produced from the common physical process, so that deviate the light beams. So including absorption, refraction, and reflection, etc. So direct front lighting. So this lighting is it emanates either from the behind the camera or from the camera itself. So that is what the lighting is. Oblique lighting. So actually it is uses a light source positioned at some low angle. It creates shadows on the surface of the evidence. So that is what the oblique lighting is. Cross polarization. So it is orthogonal to the polarization. It measures how much leakage happens between the polarization in a given antenna. So that is what the cross polarization is. And diffuse front lighting, the same. It is not harsh and direct. It is softened in some way. So that is what the diffuse lighting. Dark field illumination. So this is reflected away from the camera. And fiber optic near and lighting is, it's the safest lighting method for ponds and foundations. So we might have seen in pond, so many malls like, so that is this fiber optic near lighting. So these are the different lightings available with the machine vision. So next comes how the information is the images gets captured, and it is processed, detected by using a camera, and how it gets processed. So that is what the next steps, current steps of the machine vision. So digitalization of camera signal. So taking a analog image data and converting into digital signals. So that is what the formation of the signals here. Software uses is very important here. So software uses, you have to process the data. So the software allows the images to be processed, analyzed and stored. So there are here the different types of packages are available, and one important thing is a MATLAB. So we all know. So we are using the image processing toolbox MATLAB for processing and analyzing the data, and the image pre-processing and feature extractions are the other process that is done with the data. So image pre-processing, it needs to be pre-processed, the image, and that has to be analyzed. So noise has to be removed and contrast enhancement has to be done with the images. And feature extraction, so 2D geometric analysis is done to extract the features, and the contrast has to be enhanced. So one important thing with when you compare to machine and the humans is, so to identify a particular image, when an image is given, if you identify an object, that will be easy for the human to identify, but machine it will take, it is not that easy to identify an image. So you need a clear environment for the machine to identify the object. So that is why the machine vision is allied with the one of the technique. So the visual tasks can be very difficult for the human, but the machine has to be easily identified. So that can be done. So the natural systems take advantages that, so any disaster, same image or the same object can be visualized by a different task. So the visual task may be difficult for a human, but it can be easily identified by the machine also. So sometimes this will also be possible. So we have to train the machine. So one thing needed is engineer the environment. So the environment has to be trained for the machine to study the entire objects and features and its entire thing available, so that it will be easy to identify the process that is happening in the images. So machine vision in AI. So machine, so far you have seen what is machine vision, how it is, why it is useful, and that things we have seen. So then comes the how this is related with the technique. So how this technique is implemented in the machine vision. So machine vision is the ability for the computer to see. So it employs one or more cameras. It will convert the analog signals into digital conversion, and then it uses a digital signal processing for the communication. So the resulting data that goes to the computer or the robot controller. So it is very similar to the complexity to the voice recognition. AI techniques, some of the AI techniques that was used in the machine vision is, actually AI is human intelligence. So you have to read the human intelligence. So it will mimic some of the human intelligence, that is called the artificial intelligences. So some of the most common technique that is used with the machine vision is expert systems, fuzzy logic, inductive learning, neural networks, genetic algorithms, and spam intelligence. These are some of the common techniques that was used with the machine vision. And researchers are also going on with these techniques. So when we say about expert systems, actually it's a computer program that uses the AI technologies to simulate the judgment and behavior of the human or an organization that has an expert knowledge and experience in a particular field. So that is what the expert system is. So it consists of two main elements. One is a knowledge base. Second one is a method of reasoning about the knowledge it contains. So in the diagram itself, you can understand. So it's a non-expert user, and right side is the knowledge from the expert. So we'll be using an expert system. So the expert system is a judgment or the behavior of the human is identified, and then it gets shared between the non-expert user and the knowledge from the expert user. So this is what is happening with the expert system. So fuzzy logic. So fuzzy logic actually it's a form of many valued logics in which the truth values of variables may be any real number between 0 and 1. So usually to identify the many logical values between the two components, we'll be saying that as a 0 and 1. And here it was identified with the very specifically it was identified so that in this particular component, if it is a hot water, it was represented with a very much little and very less. So like that, the differentiation was happening. So it will give an exact information about a thing. So that is what the fuzzy logic is. So the knowledge in the system that uses this fuzzy logic will give a qualitative statements. So are some fuzzy rules for a particular thing. So that is why rules will be using this particular technique for machine vision. So this is second technique. And the third technique is inductive learning. So inductive learning is actually known as the discovery learning. So it processes where the learners are and discover rules by observing some examples. So it will observe some examples, and from that examples, it will discover the rules. So that is called as the inductive learning. So the right side of that is inductive learning. So the behavior, the picture behavior, with the behavior of the picture, so it will identify the example process that is happening in the image. So after identifying the process in the image, it will frame the rules. So that is called as a inductive learning. And the opposite to that is deductive learning. So from the rules, the examples or the implementations can happen. So that is what is called as a deductive learning. Neural networks. So it's a series of algorithms that endeavor to recognize the underlying relationships in a set of data through the process that mimic the way the human brain operates. How the human brain operates, it mimics the same way. So the relationships, the set of data can be processed with a mimic of that human brain operation. So that is called as a neural networks. And genetic algorithms. So genetic algorithms actually it is a search heuristic, that process of natural selection that belongs to a larger class of evolutionary algorithms. It solves both the constrained and unconstrained optimization problems. So based on the natural selection process that mimics a biological evolution. So it will identify a particular problem. Both the constraint and unconstrained optimization problems can be identified and it can be solved. That is with the help of a genetic algorithm. So spam intelligence. Spam intelligence, it collects the behavior of the decentralized, self-organized system, natural or artificial systems, and it is used for developing some computer algorithms and motion control principles for the robotics. So that is what the spam intelligence is. So it will identify the informations, mimic the patterns, and then it inspects the particular group to produce a smart solution. So that is what is spam intelligence. Okay, so we have seen what is a machine vision and then what are the techniques we are used in AI. So combining these techniques with the machine vision process, so there are some practical applications. So these are the practical applications of artificial intelligence in machine vision. So how these this techniques is implemented in the machine vision. So that is what the next topic is. So the first one is Pulnick's ZCam. So in Pulnick's ZCam, second one is Smart Search, third one is NeuroCheck, fourth one is Scitech iBot, fifth one is iLibrary, that is iLibrary software. So intelligent library management software. So these are the 5 different applications. So the first application is Pulnick's ZCam. Actually, this is a smart camera. It does not need any programming. What is the speciality in that is, it is a ZCam. So it it will extract 64 features. Usually the ZCam will extract 64 features, including histogram, profiles, pixel samples. So like that, it can extract 64 features. And these features are passed to a neural network, which has 74 of outputs. So the extraction can be either pass or fail of the output. So the ZCam was trained to work on these 74 classes. So that is what the main feature of this particular camera, smart camera. So they uses a neural network methods to practice or to recognize the outputs that was trained. So that is what the first thing. So Pulnick's ZCam, it's a smart camera. It does not need programming. It was trained, the neural networks are, that is information, are features are passed to the neural network, and it was trained to have a output of 74 different outputs. So your Zycam is trained to have a 74 classes of outputs. So that is what the first application, Pulmix Zycam. And the second one is Smart Search. So Smart Search is actually, it's a searching technique. So it contains a training wizard of that is based on the artificial intelligence to facilitate the system setup. So the developer need not to provide the good and bad examples. The Smart Search learns the characteristics of the object automatically, and it will identify which is a good and bad. That can be easily identified. So that is called as a Smart Search. So Smart Search technique. So actually this was provided by the Corico Imaging as a part of their Sherlock and machine vision tools vision package. So it was trained, the information was, the app was trained to collect the, learn the object, the characteristics of the object, and then it will automatically will provide the good and bad examples of the object. So that is what the Smart Search is. And the next is a NeuroChip Compact. So in NeuroChip Compact, this is also a smart camera like the Pulmix, Zycam Pulmix. So this is also a smart camera. Here they uses, so here it will compute the number of object features from the regions of interest in the image. So these features are then passed to the classification module, and then it determines the type of the region being inspected. There in the Pulmix Zycam is trained to work on the 74 classes. But here this smart camera, it can be programmed using a mouse. So it uses a package. So it can compute the number of object features based on the regions of interest in the image. So they can determine the type of the region being inspected. So that can be identified with the help of a NeuroChip Compact. So these are all trained, these cameras, these techniques are all trained with the help of the AI techniques. Next application is Sttp iBot. So the Sttp iBot is actually it learns a part form and features. So they uses a combination of fuzzy logic and neural network, both. So iBot is available in two formats. One is the shape iBot, second one is spectrum iBot. So shape iBot, it recognizes the shape of the objects that are placed in the front of the camera, and then it detects any deviation that happens from the shape. And spectrum, it identifies the color of the objects that is shown to it. So the output of the system will be from 0 to 99. So the color of the objects can be easily identified with the help of that spectrum iBot. So these are the two different iBots. So they uses the combinations of fuzzy logic and neural networks for processing. iLab library, so software. So that is intelligent library management software. So that is what the library software. So it is a library for managing books, images, etc. So it uses it provided by a multi-layer perceptron neural network. So it has many configurable parameters that includes learning rate, momentum, number of neurons, number of layers, and activation functions. So it contains a pattern recognition technique, and it uses two algorithms to identify the minimum distance and also the k nearest neighbor classification. And ANOVA, so that is the analysis of variance software. Analysis of variance software. So it's a collection of statistical models and their associated estimation procedure that is used to analyze the differences among the groups by means of a sample. So that is called as a iLibrary, ANOVA, okay, analysis variance software. So that is used for identifying the differences between the different features. So that is this particular software. So this is what the advanced search with the library, iLibrary. Next comes the challenges. So before getting into challenge, On Neon AI smart camera, that is what the feature of AI machine vision. So just we'll have a look on that.
Oh, can you tell if your cows are feeling okay? If your cows are uncomfortable, they might not produce enough milk. A comfortable environment with the right temperature and humidity will keep cows healthy and happy, maximizing milk production. When it gets too hot, AI machine vision can pinpoint the position of each cow's udders and then turn on the sprinkler to cool them down. This way, all your cows can stay healthy and produce plenty of milk. The same principle can be applied to laying hens. High-quality eggs can sell at a better price, but how do you separate all the high-quality eggs from the rest? AI machine vision can quickly check the quality of your eggs and sort them according to your quality standard. Is your farm constantly growing? How do you remove weeds without hurting your crops? AI machine vision can detect and spray pesticides on weeds directly without affecting nearby crops. This helps you protect your crops and keep yields up. Does your factory operator comply with standard workplace safety procedures? AI machine vision can identify when employees are not wearing the appropriate safety equipment to prevent workplace accidents and keep employees safe. AI machine vision can even detect hazardous chemical spills to guarantee the safety of the workplace environment. Does your production line have defects that are hard to detect using traditional AOI? AI machine vision can find defects faster than professional QC staff through exceptional accuracy and efficiency. These types of AI machine vision applications require the development of AI algorithms for deep learning. The software experts who develop AI algorithms need a smart, reliable platform for executing AI model inferencing. Neon AI smart cameras provide highly integrated, worry-free reliability and faster deployment. Neon, the future of AI machine vision.
AD-Link, leading edge computing. AI fast-tracks effective data-to-decision-based smart manufacturing. Acquired production images are a common critical data type, benefiting particularly from AI analytics. The capture, processing, and management process does, however, present numerous challenges, making it costly, complicated, and time-consuming to implement. A typical system may comprise cameras connected to a frame grabber module in a host computer, with images acquired on the line and processed by specific vision software. Processing and management of the necessarily massive amount of captured data from machine learning requires a VPU-GPU integrated vision solution or a new heterogeneous platform. AD-Link's AI plug-and-play vision system provides a fast-to-market solution with minimal investment requirement on the original platform. With plug-and-play capability and no changes necessary to other components, AI-enabled vision function is up and running in a surprisingly short time. Their alliance with leading AI brands and certifications allows AD-Link to provide native support for AI-enabled solutions, delivering the most advanced technology, shortest time to market, and maximum reliability, while proven industrial-grade AI device construction delivers rugged, reliable, and highly integrated performance. With AD-Link's leading position in the edge computing field, our cloud solution package provides fast and easy connection of AI solutions to leading cloud services, realizing your data to decision to achieve real AIoT. AD-Link's more than 20 years experience in industrial automation and machine vision means we know our customers and how to best meet their needs. AD-Link, leading edge computing.
So, challenges. So, challenges of machine vision with AI. So, the first challenge is the random object picking and pin marking. So, random box depalletization. So, random box depalletization is actually the work pieces may vary and no match with the clever schematic or schema system very clever match. So that is very difficult for the system to identify or provide a match. So the boundaries between the boxes are difficult to judge with intelligent machine visions. So that is one problem. Still, that is a challenge. And defect or identifying a defect in the flaws in the machine system, that is machine vision or the computing system, will also be a problem. And then camera mobility in the vision system. So moving up a camera to different locations to identify a particular image, the process. So that will be difficult. So still that is a challenge. High speed inspection. So any machine vision system that must run at rates of rates above 30 FPS, that is considered as a high speed application. So depending on the size of the product speeds, so it can be up to 50 parts per second. That can be incredible. So high speed inspection is also a challenge too. And vision guided robots. So that should be an accurate movement to variable target position. So a collective term of machine vision and image processing systems. It is used for positioning or detecting or inspecting with the industrial robot will also be a biggest challenge. Then multispectral imaging. So capturing image data within a specific wavelength, it ranges across the electromagnetic spectra. So this is a challenge. Polarization is the property that is applied to traverse waves that specifies a geometrical orientation of the oscillations. So that is a problem here. Then embedded vision. So integration of a camera and processing board. So integration will create the problem in the vision machine system. So vision system consists of a camera and PC, but both are very large and expensive. So still that is a problem here. So building upon information modeling and revolution in the making a revolution in the industry will also be a biggest challenge. So one that is article that was published with the overcoming this particular challenges, the machine vision with AI that solves some of the biggest societal and business challenges. So one is this article. Actually, the article, it combines machine vision with artificial intelligence. So what is a process here is they have combined these two. Usually the missing of children will be a biggest problem in the society. So the human vision, visual perception is an important main task. So to identify the missing children in the society, so they have identified, they have trained an algorithm so that it can be easy to identify or match the children's list, available list with the identified children. So they're like that they have proposed. So how machine vision can solve one of the biggest challenges this. So new images of the children will be identified, and when they comes in, the parents will be issuing photographs or like that, no? So the advertisements like that. So that will be identified and they are analyzed through the machine learning, and then the features are all extracted. The object features, the object here is the children. So the images of the pictures will be identified and it is calculated and extracted. So the feature extractions and with the numerical representations of the objects of an image, algorithms are implemented and it is facilitated to processing the images with the statistical information. So a trained AI algorithm then compare the digital representation of the image of a new image of the database with the already available thing in the database. So if there is a match, then there is a possibility of a sim that is a victim of that particular image. So this can be identified by using a trained algorithm. So what they have used for that, applied or used for that technique is MemSQL. So for that technique, so MemSQL actually it is a single store modern relational database that is used for cloud, and it is a distributed relational SQL database. Its features are that feature with the ANSI SQL support for speed and data in digest, transaction processing, and query processing. So it runs in various Linux environments. So they uses this particular MemSQL, and the MemSQL dot product identifies, it calculates the feature vectors of multiple images with a low computational workload, and then it compare that particular feature informations with the already available images, and then they have identify the match with the images. So that is with the help of the MemSQL. So the first thing is needed thing is this. So you have to train the AI deep learning system with the known available inputs, and then once the data analytics part is completed, so then it can be implemented using any one of the technology with the help of the MemSQL. The features are calculated, feature vectors are features are extracted and gets calculated with the deep learning algorithm. So this is what is done, and the overcoming challenges. The challenges that was represented earlier that can be overcome by using some self-driving cars. So self-driving cars that utilize the machine vision along with the other sensors for control functions, and it is very important, including all the important collision avoidance. So it will be easy for the particular person to pick up things that humans will not be doing it. So that is what the major purpose. This is what the self-driving cars. So soon we are awaiting for the self-driving cars in the near future. And the survey. So this represents a survey on the AI-based machine vision. So what is this survey represents is what are the major issues that currently we are focusing on visual inspection method, and how come it is related with the AI. So 56% of the false calls, that is incidents of good part being marked as a defective part. So that was happening 56% of the 100 thing, that is 56% that was happening. This was a main issue in that. And 50% is inability due to some inspections. Inability of something is missing out, some data can be missing out, inability for a thing to continue. So that is 50% of that is happening that. And inability to deal with the variations in what is being expected is 42%. And the labor cost is too high, so that is 41%. And 13% of expensive and maintenance cost is also too high. So these are the major issues that we face with the current visual inspection method. And what is a key finding in the survey of the AI and machine vision is 15% is it is overall opinion of the effectiveness of AI with machine vision. 15% is it's very high, 39% is a high, 28% is moderate, 4% is low, 2% is it is not effective, and 12% is that some of the people are not aware of combining these two, that is AI and the machine vision. So this is what the overall opinion of the effectiveness of AI with machine vision. So only 15% is very high. So that has to be improved still. So you have to create an awareness, and the effectiveness of the AI should be known to more number of people to build a better system. And the benefits of machine vision with its applications. So benefits here, one is a high performance with the high quality, and production is flexible. Machine is less machine downtime, complete information and process control, capital equipment cost, lower production cost, and inventory control and reduced floor space. These are the benefits of machine vision system. So machine vision system altogether, when it combines with any of the technology, so it's a technology that allows the computing device to inspect, evaluate, and identify still or moving images. Anything can happen. So AI is used in the machine vision system for continuous improvement in recognizing an object and how it gets applied. So deployment in a scenario in which the vision systems are used for object recognition is also an important point here. So incorrect predictions can be easily identified and it can be recorded, and the vision system can continuously learn and improve itself by knowing its own mistake. So identifying its own mistake, the machine itself can train for a better result. So these are the three basic types of machine vision system: 1D vision, 2D vision, and 3D vision. So 1D vision, it analyzes signal one line at a time. And 2D signal, it can capture the image of the object with a two-dimensional map of a reflected intensity. And three-dimensional vision, so it is typically a 3D machine vision system. It includes multiple cameras or one or more laser displacement sensors for identifying an image. Uses of AI in vision applications. One is the rise of industrial Internet of Things. So that is a major thing, very important thing. Industrial IoT. So it refers to the interconnected sensors, instruments, and other devices. So it is a network together with the computers, industrial applications. So it includes manufacturing and energy management also. So that is the use of IIoT. So for inspection applications, for instances, this accurately translates the productivity, and for profitability it will be useful. And these are all some of the strategic goals and the machine vision applications. So when we consider the goal is high quality, high productivity, production flexibility, like that. So the applications can be, so it can be easily measurable. So machine vision can be easily measurable, and it can be used for some robot guidance. And when the machine downtime is very less, that there needs a changeover in the program in advance. So when there is a downtime, there needs a changeover in advance. So when more fulfilled informations are given, then manual tasks can provide computer a feedback, so that it was fulfilled with some information. So next, the processing control will take over with the available feedback. So that will be better. So reduce capital equipment cost. So it will be for improving its performance, so that we can avoid the obsolescence. So production cost is very less, means one vision system with many people, it can be worked on that. So to identify the flaws early in the process can be reduced in the production cost. So scrap rate reduction. So this can be inspected, measured, and the gauge measurement can be calculated, and gauging system can also be improved. So manufacturing process means more than making cuts efficiently, it requires either the right tool for job to maximize the efficiency. So these are the specific goals, and how the machine vision, how AI brings values to the industries. So nowadays, industry 4.0, industry 5.0, that everything comes into picture. So enterprises are moving towards the AI applications. So enterprises are multiple types of AI applications are used. So 1 in 10 enterprises are using 10 or more applications on it. So AI becomes a vital role in across the industries. So machine vision, it enables the machines to identify the object, analyze the objects, and it's a visual environment. So AI systems can help the humans. It becomes more effective, assist them, and with the repetitive tasks. So this can be useful to that. So manufacturing industry 4.0, highly optimized AI algorithms that take pictures, analyze them in real time, and notify other systems immediately as faulty products or irregularities are easily identified. So making a machine vision smarter with AI. So how can we make the machine vision smarter with AI? Because AI is a human intelligence. So how can we apply this? So if these questions are answered, then it can be smarter with AI. So there should be a specific machine vision application so that it will create a biggest impact on the AI. That is first point. Second thing, we'll be using some leverages to the AI. So the success keys or leverages to the AI should be a part of a machine vision application. So then you'll get a better machine vision. And the challenges which we face has to be overcome with the manufacturers. So need to be overcome so that your machine vision will be smarter. And the effective uses of AI should be continued with the machine vision space. So that machine vision and AI both will grow with each other. So are there specific machine vision applications where AI has a biggest impact? Yes. So traditional machine vision automated optical inspection that works well with objects with the minimal variations. So the AI is powered vision. It detects its speed, accuracy, and with low cost. So it excels its task with the segmentation, classification, verification, processing of images that are all done with the processed images. So the images. So the specific machine vision application that has a biggest impact on the AI. So why do we see as the keys to success leveraging AI as a part of the machine vision application? So there are three keys to have a success on AI. One is developing an efficient AI for data acquisition management. Second one is establishing a robust process. Third one is bringing up different stakeholders so that you can ensure that it's ready to embrace the AI. So these are the three different keys to have success on AI. What leverages or what challenges do the manufacturers need to overcome? So top challenges is small data, ambiguous defect requirements, changing environment and the requirements has to be overcome, and then compounding complexities that should be overcome. These are the top challenges. If these are all overcome, then your machine vision will become smarter than AI. So how do we see the use and effectiveness of AI continue to evolve within the machine vision space? So AI is a powered vision application. So it is still in the early stage of manufacturing. So when we deploy some typical inspection on AI and significantly with the less resources, then with the AI platform, so it will be better with the machine vision space. One example is Audi car. So in Audi, Audi car, so it's a pioneer and in using AI-based vision for visual inspection. So the company recognizes the marks or cracks in the sheet with a deep learning algorithm. So they have identified the software that is used in the company can detect the finest cracks in the sheet metal. And they developed the system so that it will give they have trained the artificial neural network with several million test images from 7 presses at Audi's plant and from the Volkswagen plants. So this is one example. So solving some visual inspection problems using AI. So with landing AI's end-to-end inspection platforms, a global manufacturer was able to improve the AI from 76% accuracy to 93% accuracy. So this can be happened. So this enabled more accurate detection of steel defects. So that is why most of the leading companies are making use of artificial intelligence for their processing. And these are some of the related researches. So the research on intelligent recognition of train image based on the machine vision. Actually, they have studied the image fusion, and then they have Data fusion technologies are analyzed, and their images are captured, and they have trained the images, and they have used some wavelet transform for merging, and then the weight average fusion method is used, and the results are all compared, and the successive implementation of the wavelet transform is proved in this particular paper. And the next paper is pattern design of knit and the pearl based on the CAD system of automatic knitting machine that is based on the computer vision integration. Here the knitting machine, CAD, and the knitting experiment. So they summed up the system in a different combination of needle, and the design of the original deviation and the pattern deformation is analyzed, and they combined the machine vision technologies are combined, and they have achieved an automatic analysis. So the experiment results are validated with the effectiveness of the process. And machine vision based localization of intelligent vehicle. They have proposed some algorithms with a good adaptive ability, and when roadway structure needs some changes, they have illuminated with the control conditions, and then this was identified and proved with the machine vision based system. And one interesting paper is the Mango classification based on machine vision and artificial intelligence. Mango classification. So what actually they have done is, the steps are involved in this mango classification is actually the mango, the fruit classification of mangoes. So the sorting and classification of this mango, there are with different colors, weight, size, shape, and density. So with that, it has to be separated. So currently, by manually, the farmers have the awareness of low accuracy and high cost and health defects, and costly, economically inferior. So what happens is the internal quality of the mango, such as sweetness, hardness, its age, brittleness. So it is very important. So it cannot be easily estimated by the external. So what they have done is, it is necessary to use artificial neural networks to solve this problem. So they have used artificial neural networks to solve this problem. How they have implemented is, the best quality is so the quality assessment of the mango fruit has not been resolved. So the application of image processing technology, computer vision, combined with artificial intelligence, they have identified the quality of the mango, and they have studied out, they have created a system that can classify the mango in terms of color, volume, size, shape, and fruit density. And then the classification system, it uses an image processing technique that incorporates the artificial intelligence, including the use of CCD cameras, and then C language programming, computer vision, and the neural networks, artificial neural networks were used in that. So the system uses these methods to determine the mass, volume, defect of the mango fruit surface. They determine the density of the mangoes related to the maturity, sweetness, and the percentages of the quality of the mangoes that can be easily identified. So they have identified the research issues. They learned the local mango assessment and classification criteria. They developed the classification methods. They arranged the classification stages. They conduct some analysis on the appropriate options, and then they designed the classification model to meet the objectives. And then the classification methods, they have built some algorithms to identify the efficiency of the highest thing, and then they implemented with the local design. And this is what the steps they have done. They have taken the list of the fruit mango. They have image was the image acquisition was done using a front and back of the mango. Segmentation was done with convolution filters, and then post processing of the segmented images that has happened via AI-based technique. Feature is extracted, so size, color, and defect is all extracted, and the synergetic classification for feature combination is done. And then with the expert system, grading. That is rule-based algorithm is used here with the expert system grading. So they have graded the mango. So the mango, the grading of mango can happen like this. So the table, this table will that will easily gets converted into a rule-based expert system. For better results, fuzzy rules can be employed to emulate the expert human grades more closely. So the segmentation methods used here, based on the standard image processing functions, it consists of 3 stages. So 2 images of the surfaces being inspected is acquired using the image from the above and the beneath the mango. So these images contain some features that is caused by a classification. So the table, it shows a grade, its number, type, and the size of the defects. So size of the defects is identified here. And then the right side of the picture, it represents the bricks level. So what is a bricks level is actually, bricks level is a percentage of solids that is present in the juice of a plant. So if you're taking a juice of a plant, what is the percentage of the solid that is in the fruit? So that is called as a bricks level. So the bricks level of the plant is identified. That was calculated here with the mass, length, width, and the volume. And with these, they have optimized the bricks level. So they have optimized the neural network for predicting the mango's bricks level by using a neural network. So the output of that, the table, so error rate table. So that identifies the error table between the weight of the mangoes that is calculated, actual value, and the volume that is calculated by the equation. So they have found out what is a error, are the differences between the two. So after calculating this, the implementation part is this. So they have implemented the binary image is it is converted into a grayscale, and then they have implemented a contour algorithm that is used in the image processing. So to separate, extract the objects, and then they have classified, they have used some classification technique. So to finding out the largest area of the disability. So the disability area is the larger area, and that has to be identified. And the mangoes are all, the disability area is then allowed, and the mangoes are removed, and the results are calculated with the actual size of the sample mango. So its length, width, and the height are all calculated, and that is what the final picture, so final image that represents. So this is what is implemented as a result. And these are all some of the references. Before one day, I just want to show 2 more videos. Actually, the Industry 4.0, which we are discussing. So Industry 4.0 and the machine vision. This is a video on that.
What will the manufacturing of tomorrow look like? Industrial parts are becoming smaller. Products get to market with less waste, faster, and on time. Even the most manual processes are turning towards automation. Innovations in machine vision, deep learning, and robotics are revolutionizing production lines and supply chains. Our machines now produce vast amounts of big data, accessible via the cloud. As machines and the information they produce become linked, new cyber-physical systems will spark a modern-day industrial revolution. This is Industry 4.0. In Industry 4.0, smart machines learn from their environments and take corrective actions to optimize production. These machines work independently of a central controller, collaborating and communicating with other devices. Industry 4.0 factories produce new organizational intelligence, which spreads across facilities and is accessible anywhere. The result? Nothing short of total transformation of production lines and business performance. Machine vision will be at the heart of this new manufacturing paradigm. At Cognex, we are already offering Industry 4.0 ready solutions to help manufacturers innovate for the future. From the very first networked vision system, Cognex products have been able to communicate with other devices on the line and transmit manufacturing data. Cognex Connect links PLCs with a factory's networked devices for data collection across plants and global networks and insight into operations and performance improvement. Sensors guide and communicate with collaborative robots, which work safely alongside humans. Real-time monitoring capabilities anticipate and accommodate changes and adjust based on incoming data.
I just want to share the project ideas related to the machine vision with AI.
Hello, welcome to the postgraduate program in Artificial Intelligence and Machine Learning offered by the University of Texas at Austin.
Get ClickUp's unlimited plan 15% off for life this month only. Assign and organize tasks with Gantt charts, collaborate with your entire team.
So that was the project ideas in all the three levels of basic, medium, and it is advanced level. So I think so that is what about effects of AI in machine vision. So I think I have come to an end of it. So the references which I have shown is that other websites of references. Sincere thanks to HOD Ma'am of EC Department, Community Institute of Technology, and Professor Arun Sir for giving me this opportunity to deliver a session here. So hope all the participants gained some knowledge about machine vision with artificial intelligence. Thank you participants and the team for patient listening. So thank you. Thank you Arun Sir, it was very well organized. Thank you ma'am, thank you.
Thank you ma'am. Participants, if you have any queries you can ask.
Yes,
and there is one question in the chat box, ma'am.
One question, okay, I'll take it. Actually, the inductive learning is, so the question is neural science behind the inductive learning. Okay, so fine. Actually, the inductive learning is discovery learning. So the process where the learners discover rules by observing the examples, with the examples, observing some with examples. So neural science, so related to the inductive learning means actually it is a multidisciplinary science. So it combines all the physiology, anatomy, molecular biology, and cryptology, mathematical modeling, like that. It will combination of different multidisciplinary sciences. So here also there is a combination of AI and with machine learning. So different AI techniques combined with the machine vision system, so that you can have a combination of these multidisciplinary sciences to get a better vision system. So that is what the inductive learning comes under the category of machine vision combination. I think that that was the answer, sir. Shankar, sir.
Thank you.
Thank you, sir. Thank you.
Yes, participants, if you have any other queries, you can ask. Okay, ma'am. On behalf of Funny Institute of Technology, I would like to extend my heartfelt thanks to you, ma'am, for sharing your knowledge and time for us. The examples and the videos you have shown or shared is very nice, ma'am. It makes us to make the concepts clear and understand it very well, ma'am. Thank you, ma'am. Thank you for it. And as a token of gratitude, we would like to extend, we'd like to present a virtual memento for you, ma'am. Kindly accept it, ma'am.
Thank you. Thank you so much. Thank you, Pratika, ma'am. Thank you so much.
Thank you, ma'am.
Thank you so much. Arun, sir, thank you so much. It's a very well organized program. Thank you.
Thank you, ma'am.
Thank you.
Participants, the feedback link, thank you, ma'am. The feedback link will be posted in the chat box. Once you fill the feedback, you can leave the session. Thank you, ma'am.
Thank you. Thank you.